Let's discuss LeetCode problem number 15, threesome, Java solution. I think I would have picked a different problem title, but let's go with the current title. And so you are given a list of integers, and you are supposed to return three numbers which will add up to 0. So in this case, -1, -1, 2, and then -1, 0, 1. So the solution must not contain duplicate triplets. So if you see, there is a difference. Like, you can have duplicate numbers, but you cannot have duplicate triplets. So you can have duplicate numbers within the triplets, but the triplets themselves cannot be duplicate. So you cannot return another -1, -1, 2, and that's the reason why you have this one I equals to j, because there are like two -1s here. You can satisfy this condition, I is not equals to j, I is not equals to k, and then j is not equals to k, as such that this one equals to 0. If you just, without this duplicate triplets, if you just apply this constraint, you will return two of these. And so, but you need to, this constraint basically make sure that you need to eliminate that duplicate triplet thing. And let us take a look at the Java solution. So the strategy is basically you use a modified version of two pointer. So you run through the first one, you run through from, because you need three numbers, so you just once you pivot the I from 0 through length -2, and then you basically left and right, you use the two pointers left and right, and then add the sum I and then left and right to come whether it is the sum turns out to be 0 or not. You need to sort first, because for this two pointer technique to work for everything, like if sum is less than 0, left plus plus, right plus plus, for that basically assumes that the array is sorted, and in the input problem the array is not sorted. As have you seen that -1 and -1, they don't appear next to each other in the problem, example problem of LeetCode. So you sort the array first, and this is the result list of arrays, each list representing a triplet. So as we discussed, like we move I from 0 through length -2, and so you because at each stage for I, j, and k, if there are duplicates, you need to avoid them. So that's why if you need this condition, if nums I equals nums I minus 1, you continue. And so then you start left at I plus 1, and then right you start with the last element on the right side of the input array, and then this is the two pointer logic. While left is less than right, then you add all the three numbers. If sum equals to 0, then we got a hit. So you just add that list, I, left, and right, and then you need these while loops to avoid the duplicate. So if there is nums left equals to nums left 1, you use left plus plus, and then nums right equals to num right minus 1, because right is moving from the end of the array to inside. So you do right minus minus. So with these three conditions, this one, and this one, you are making sure that there are no duplicates, and this one is also part of the problem, means part of the solution. So these four statements make sure that you are not returning any duplicate triplets. So now you found sum equals to 0, and so once you found the triplet, so now you need to do left plus plus and right minus minus, because you need to do both so that you don't get the duplicates. Otherwise, if the sum is not equals to 0, if it is less than 0, then you basically have to, left is it's going in ascending order. So sum is less than 0 basically means you need to move the left. It is the sum is still negative, so you need to move left plus plus, otherwise you move right minus minus. Sum is greater than 0, so you move from the right to see if you can find the triplet. So at the end of it, you return the result. Let us take look at this, run for this one, -4, -1, -1, 0, 1, 2, and this is already sorted. This is not the actual input. And so you just do first element, you start from -4 and then you pick -1. See, this left becomes -1 and right becomes 2, and then you do sum is -3, so sum is less than 0, so you move the left pointer and try once again. -4. Now once again, because even though you move left, you still run stuck with the same problem because these two are duplicate. And so now sum is less than 0, so you move the left pointer, and now you come to -2. Once again you move the left pointer, and then -4, 1 and 2, and so move the left pointer. And so for the when I is -4, you don't get any triplets, so you just move I here, and then left is this, and then right is here. At that point you find the triplet. Sum trying -1, sum equals to 0, and so you found the triplet. So now you move left plus plus and right minus minus, so you find another triplet here, and at the end of it you I when does the I end? So I comes here, and then left is less than right. That basically ends the loop, and so you found the two triplets, -1, -1, 2, and then -1, 0, 1. Comment below if you have any questions. Otherwise, I will see you in the next video. Bye.